Time now for Space Watch. I'm joined by Brad Tucker, the ANU astrophysicist, and I'll just call you the Sky News resident space expert.
Sure, yeah, that's right. Fine. Yeah, well, look, sky's in the name, right? You know, sky,
true.
space.
Your employer won't mind, I'm sure.
Yeah.
We'll split your salary. A big new health impact for astronauts,
Yes.
in fact. So we're talking DVT. This is the thing that popped up years ago on flights.
Yep.
Blood clotting, basically. How is this just getting found out? Wouldn't this have been happening for years?
Well, that's probably the real issue. It probably has been happening for years. You know, so this is, you know, your ordinary astronaut. And what you can see is that, you know, even liquid doesn't flow the same. Now, when you see every astronaut in space, they have essentially a very puffy head. And what's going... Yeah, it's a well-known syndrome. And that's essentially, right, there's very little gravity. So instead of gravity pulling blood down naturally, it starts to build up in your head.
So it's just puffy compared to us and what we perceive normally.
Yeah, exactly.
Normally the blood's going out of the head. If we were on a different planet that had less gravity, we'd all have bigger heads, I guess.
Well, or we would have adapted for that, exactly. So it's, you know, it's kind of that our gravity and the pressure in our bodies used to flowing in a similar way. You change the gravity and then your blood flow changes. And what they did was they did a study of 11 astronauts and they looked at the blood flow through the jugular, essentially, you know, the main blood vessel between the neck and the head.
Yep.
And what they noticed that 5 of them had problems in the flow to their brain compared to what they were.
Is this after they'd returned back home?
So this is in space.
Right.
So you can actually see his head is kind of, it looks a little bit like he's straining almost. And especially if you see side by side them pre-flight and in-flight, their head really is that. And so with that water, what they found is that's starting to do what the blood is doing, right? It's starting to pool in the neck, and when blood pools, you get clotting, DVT. And they found that in space, one of these astronauts actually had a clot. And you can imagine if the clot becomes loose, just as in an airplane with DVT, if it settles in a part of the body.
That's the big issue. Clots happen all the time. It's when they get loose, they break off, or they can go to the heart or the brain.
Heart or the lungs, right? Yeah, so if it goes to a major bloody, blocks that, you can have an issue. So there's always been this worry that it's happened. They've known that blood problems have happened before relative to their eyes. So astronauts have vision problems. And that's actually what they're trying to study. Why are they having vision problems? And so they're looking at the blood flow going to it.
What can they do about it?
Look, this is a big issue. What can we do about it? So obviously a lot more study has to happen. And, you know, obviously the next step is not necessarily just for the astronauts, but if tourists are going to start going to space, people already have blood problems, what's going to happen to them?
They won't be as fit as these guys, will
Exactly. You know, these people are selected genetically sometimes to be fit. So this is going to raise an issue about how does that happen. Okay. You know, you can't exercise easily in space.
So they get all these zero gravity chambers in Earth or in planes and so on. Can't they have gravity chambers up in space?
So you can simulate gravity. The best way to do it is to create some sort of force that simulates it. The problem is...
Spinning around or something.
Yeah, that's a classic example. It's energy and cost, right? How do you do that? And that's the quintessential problem.
It's got to mine water on the moon. We know that. Earth, speaking of moons, might have, had a mini moon, so it's not there anymore?
No, so there's this kind of new thing that we think Earth has mini moons. When we think mini moons, we're literally talking about small ones that can burn up in the sky, like in these meteorites. A meter. So essentially the idea is if you get an asteroid that comes close enough to the Earth, Earth's gravity pulls it in, it gets stuck orbiting around, and eventually comes down. So some researchers in Australia have set up a network of cameras all across Australia to find meteorites as they come into the sky and track where it's come from the solar system. And they found one in particular didn't come from somewhere else, but came from obviously orbiting the Earth. And so the idea is that our Earth can collect things, these mini moons. Now, when you think about it, all right, well, what does that mean? Well, if we're collecting asteroids and not just asteroids hitting the Earth, then eventually asteroids slowly burning up in the Earth's atmosphere, potential collisions with things, potentially falling in places.
Could we get a whole, many years beyond our futures, unfortunately.
Yeah.
Could we get a little belt going?
Look, if it happens the right way, you could get a collection of these that would just stay in orbit.
Ones basically happen?
Yeah, exactly.
So why does this one come to Earth and the real moon, Moon 1.0 I'll call it.
The original, yeah.
Sits there. Is it about the size? It's too big to get sucked in?
So there's two things. One, it is related to the size, how much mass it has, but also it's actually how the moon formed. Since the moon formed with a collision with something in the Earth, the moon's actually been slowly going away as opposed to all the other ones happening.
If it had come in on a different angle, it would have come right through and we would have...
Exactly. So this is happening to Mars's moons. They're slowly colliding with Mars.
All right. Speaking of Mars, we're doing good segues today. We've got a weather storm there. So Mars has dust towers that are 80 kilometres tall?
So this is something that we haven't ever seen before. So Mars has been known now to have global Mars weather systems where the entire planet is enveloped in a dust storm. This happened last year. We talked about how it actually knocked out one of the rovers because the whole planet was enveloped in dust for 4 months. Now what we're starting to find is that during these storms, that there actually could be huge towers of dust coming into it. So when we look at Mars, we don't see a lot of this. We just see kind of a thin atmosphere, and this is an animation of landing on the planet. But what happens is that in the right conditions, like a dust tornado, but it ends up being a column 80 kilometers tall.
Why wouldn't we have seen that before if it's so tall? And
so these actually can be the size of Tasmania. The problem is they tend to occur when the entire planet is in a dust storm. So it's kind of like the weather we're having in Sydney right now, right? Where it's hard to see some of the subtle features. The more important impact of this is if there's an entire dust storm that is the size of Tasmania sucking things out, this actually will suck out air, it will suck out water. This actually could have led to why Mars lands up. And if this happens once a decade, it is kind of currently happening, how are humans and things when they land on Mars going to prepare for a Tasmanian-sized 80-kilometer dust storm?
With great difficulty, I would suggest.
Yeah.
How can Mars have one weather system that affects the whole planet and that would never happen here? What's the difference there?
So there's a couple things. It's the atmosphere composition. It's a lot of carbon dioxide. It's also the thin atmosphere. So the atmosphere pressure is about a sixth that of Earth, which means it doesn't create you don't have that much of a turbulence to create a bigger storm. If you think how cyclones and hurricanes change size based on how much energy and pressure change, because there's already a sixth of that, it can become quite big in comparison. And the fact is then it's a reciprocal issue, dries up, more dust storms, bigger dust storms, and so on and so on. So it's only going to get worse in the future.
It's like the science class I never listened to at school.
Exactly.
Tucker, we'll talk next week.
Thanks.